All right, today we're going to look at 2.1, day 2, and this is going to be about transforming data. All right, let's look at the effects of adding or subtracting a constant to each observation. So when you add a number to each observation, this is also going to add the same constant to the measures of center and location, such as the mean, the median, the quartiles, percentiles are a few examples. This does not change the shape of the distribution. So if it was symmetrical, adding a number to each observation will also produce a symmetrical distribution. If it was skewed to the left, adding a number to each observation will still remain skewed to the left, and so on. Note that this does not change the measure of spread. So the range will not change, the IQR will not change, the standard deviation will not change, the variance would not change, so on and so forth. All right, so let's look at an example. A school system employs teachers at salaries between $28,000 and $60,000. The teachers union and the school board are negotiating the form of next year's increase in the salary schedule. So if every teacher is given a flat $1,000 raise, what will this do to the mean salary, to the median salary? And explain our answers. So first, just like we talked about before, the mean and median will increase. So, comma, since, actually I should put increase by 1,000. Since the distribution will shift over $1,000. So basically the entire distribution is going to move to the right 1,000 places. And so the distribution, the shape of the distribution won't change, the spread of the distribution won't change, the entire thing will just move 1,000 numbers up. If you think of it like a number line, scoot down 1,000 on the number line. Therefore the mean and the median will also scoot down $1,000. So what would a flat $1,000 raise do to the extremes and quartiles? Well, the extremes and quartiles are locations in a distribution, so they will also move. Extremes and quartiles will increase by 1,000. And it's the same explanation as above because the entire distribution will shift down $1,000 or shift over or to the right 1,000 numbers. And then what about the standard deviation? Well, again, all we're doing is shifting it down the number line, all right, shifting it 1,000 places on the number line, so we're not changing the spread. We're just picking it up and moving it and putting it somewhere else. So the standard deviation will not change. Sorry, it's hard to write on this today. It will not change. Okay. So what about multiplying? So this is different. Notice that this is for multiplying or dividing each observation by a constant. And really this matters because later we'll talk about some other things that happen, but this is each observation. So if you multiply or divide each observation by a constant, then we also multiply or divide the measures of center. So the mean, median, quartiles, percentiles, etc. also increase by the same multiplication or division. Does not change the shape of the distribution. So this does not change. But notice that it also changes the spread, and it's by the absolute value of the constant. So spread can only change in a positive fashion. Spread is never negative. So we have range, IQR, standard deviation. Okay, so it's going to be multiplied by the absolute value of the constant. So now, if each teacher receives a 5% raise instead of a flat $1,000 raise, the amount of raise will vary from $1,400 to $3,000, sorry, depending on the present salary. What will this do to the mean salary, the median salary? So the mean and the median will increase by 5%. All right, and so explaining our answer is just because Each observation is increased by 5%, so therefore the mean and the median will increase by 5%. Will a 5% raise increase the IQR? Yes. Because we are increasing the spread of the spread of the distribution. Will it increase the standard deviation? Yes. Does the 5% increase will increase the spread of the distribution. Okay. So number 3, Brandon measures the diameter of each tennis ball in a bag with a standard ruler. Unfortunately, he uses the ruler incorrectly, so that each of his measurements is 0.2 inches too large. Brandon's data had a mean of 3.2 inches and a standard deviation of 0.1 inches. Find the mean and the standard deviation of the corrected measurements in centimeters. So let's look at the mean first. So the new mean is going to be the old mean minus 0.2. So the new mean is going to be 3.0 inches. Then we need to convert that to centimeters. So 1 inch goes on the bottom, 2.54 centimeters goes on top. Multiply straight across and we get 7.62 centimeters. All right, and then the new standard deviation. So that's 0.1. Remember that standard deviation does not change and add or subtract, so I'm not going to subtract 0.2 from it, but I am going to multiply it by 2.54, which is just going to move the decimal place one place to the left, so 0.254 centimeters. So make sure we understand this. There's a similar test question and a similar quiz question. All right, so let's talk about density curves. We've kind of already been talking about density curves. We've been drawing that normal curve on the board, and that's kind of what that is. So all density curves are always on or above the horizontal axis. They also have an area of exactly 1 underneath it. The density curve is described by the overall pattern, sorry, add an end to that, of a distribution. The area under the curve and within 2 intervals is the proportion of observations that fall in the interval. So if that doesn't make sense to you right now, don't worry about it, because we will do plenty of that soon enough. So let's fill in a blank here. The median of the data set is the point with half the observations on either side. Therefore, the median of the density curve is the equal areas point, which is the point with half the area under the curve to its left and the remaining area to its right. So if you think of a density curve, it could look like this. This is what it's talking about. This is the median, where 50% of the data is over here and 50% of the data is to the left. All right, so number 4. The figure below displays the density curve of a uniform distribution. The curve takes the constant value 1 over the interval from 0 to 1 and is 0 outside the range of values. So basically we just have this square. Uniform distribution is always going to look like a square or a rectangle. So explain why this curve satisfies 2 requirements. So there's 2 things that has to happen. It has to be above the horizontal axis, above or on the horizontal axis. So we are above the horizontal axis. The other thing that has to happen is that the total area under the curve, in this case the straight line, must be exactly 1. So if we find the area of this, 1 times 1 is 1. So our area is 1. What percent of the observations are greater than 0.8? So if this is 0.8, right? So if we drew a line straight up, this would be 0.8. Whoops, pretend like I just shaded in the green area. Then what's left would be 1 minus 0.8, which is 0.2. What percent of observations lie in between 0.25 and 0.75? So you just take the bigger number minus the smaller number. And that's what that was talking about on the slide before, about the area that lies in between two intervals. So 50% of the area under the curve is equal to 50% of the observations that lie in between 0.25 and 0.75. What is the mean? Well, the mean is, in this case, because it's symmetrical, the mean is in the middle and the median is in the middle, so both of them are 0.5. So hopefully that makes a little bit of sense. We'll talk about it a little bit more tomorrow as well. All right, the figure below shows two density curves, each with 3 points marked. At which of these 3 points do the mean and the median fall? So the median divides it into two 50% pieces. So we can see A divides the curve symmetrically. So A would be the median. And because this is symmetric, A is also the mean, because we know that in a normal distribution like this, in a symmetric single peak distribution, although also known as bell-shaped, then it's the mean and the median live at the same place. All right, so now this B is skewed. So we have to look at where the 50% piece is. If we look at C, C has too little area to the left and too much area to the right. So C is the mode because it's got the peak. B, you can tell that it's divided the area into half. So the 50% of the area is to the left of B and 50% of the area is to the right of B. So B must be the median. And because this data is skewed to the left, the mean gets pulled towards the skewness. So A is the mean. I know we've went over that many times, but that's because it's really important. All right, so let's look at some of these multiple choice questions because they're pretty similar to the ones that are on the test. So George has an average bowling score of 180. So this is our X. And bowls in a league where the average for all bowlers, so average means mean, and the standard deviation S is 20. And Bill has an average score of X and bowls in a league where the average is 160, so that's X bar, and a standard deviation S equals 15. Whenever you see X, X bar, and S, that's a pretty good indicator that you need to find the Z-score. So who ranks higher? So these are two separate distributions. It's George's league and it's Bill's league. So they're two separate distributions, which means in order to compare two separate distributions or two locations in two separate distributions, you must use the Z-score. So let's do the Z-score for George first. So that's the score minus the mean of that distribution divided by the standard deviation of that distribution. So that would be 1.5. And then Bill is equal to X in his distribution minus the mean of his distribution divided by the standard deviation of his distribution, which is 2.0. So Bill, because it's 190, no, because that's just the score, so you can't compare two scores in two separate distributions. Bill's, because the standardized score is higher, that's true. So the answer is B. All right, look at number 7. If 30 is added to every observation in a data set, the only one of the following is not changed is. So is not changed. Which one does not change? So the mean will change. The percentile is a location. It will change. The median is a location. It will change. The standard deviation is a type of spread. It will not change. And the minimum is a location. So if every observation in a data is multiplied by 10, which of the following is not multiplied by 10? The mean will be multiplied by 10, the median will be multiplied by 10, the IQR will be multiplied by 10, the standard deviation will be multiplied by 10, and remember that variance is S squared, so this would actually be multiplied by 100, because it's always square everything else. Tricky, tricky. Number 9, scores on the ACT college exam follow a bell-shaped distribution with a mean, so we know that X bar is equal to 18, standard deviation is equal to 6. Wayne's standardized score, standardized means Z-score, so Z-score is equal to -0.7. So what is Wayne's actual score, which means X? So basically we're using the Z-score formula and we're going to use algebra to solve for X. So plug in all of our numbers. So the Z-score is -0.7 equals X. The dog's digging into stuff. X, we don't know what it is, so it stays the same, minus 18 divided by the standard deviation of 6. So all we do is solve. So multiply both sides by 6, and we get negative 4.2 equals x minus 18. Add 18 to both sides, and x is equal to 13.8. Yikes. Hopefully he plans on taking that again. All right.